let us prove this. Okay. Now, let us consider here u as 1 by x, okay, and v as log x. Now, we know that un is equal to minus 1 to the power of n into n factorial by x to the power of n plus 1, right? And vn will be minus 1 to the power of n minus 1 n minus 1 factorial by x to the power of n. Okay. So let us apply Leibniz theorem here. Yeah. Now we know that u v n is u n v plus nc1 u n minus 1 into v1 plus nc2 u n minus 2 v2 plus so on up to nc n minus 1 u1 vn minus 1. Yeah. Okay. And
Yes, sir.
And which is equal to u v plus, sorry, that's the last one, right? Okay. So we know this formula, right? So let us substitute it. All the things which we have. So that is un, which we have found as minus 1 to the power of n factorial by x to the power of n plus 1 log x plus nc1, okay, nc1. This will be minus 1 to the power of n minus 1 into n minus 1 factorial by x to the power of n. v1 will be 1 by x, okay, and nc2, we'll write this also, nc2, which is minus 1 to the power of n minus 2, okay, into n minus 2 factorial by x to the power of, this will be n minus 1, okay, and this will be minus 1 by x square and so on, okay. So nc n minus 1, okay, u1. So this will be minus 1 by x square, right? Okay. And minus 1 to the power of n minus 2, okay, and n minus 2 factorial by x to the power of n minus 1 plus 1 by x minus 1 to the power of n minus 1 and n minus 1 factorial by x to the power of n. So we get this. Now further, when we simplify this totally, so we get minus 1 to the power of n into n factorial by x to the power of n plus 1, okay, and this will be log x minus 1 by 2, okay, minus and so on n minus 1 and minus 1 by That's it. So that will be the final answer when you take things common. Okay. Let us differentiate this equation now. So we have to differentiate each terms of the given equation n times by using Leibniz theorem. Okay, so that is dn of 1 minus x square into y2 minus, or we can take that on the right hand side, is equal to, okay, so let us do the first one. Okay, let us do this, which will be 1 minus x square. Now this will be y n plus 2. Okay, so now plus, now we have nc1 by using Leibniz. nc1, this is minus 2 x, because differentiation of 1 minus x square is minus 2x. Okay, and this will be y n plus 1 plus nc2, right? And differentiation of minus 2x will be minus 2, and this will be yn. We got this. Okay. Okay. Now further, 1 minus x square. Okay. In this we have to write this. nc1 will be n. Okay. But since it is minus, so let us put that minus. This will be minus, okay, 2 into n into x y n plus 1. Again, this is minus, right? N into n minus 1 by 2 into 2 yn, right? One minus x square and yn plus 2 minus 2 nx yn plus 1. Okay, by cancelling 2, we get n into n minus 1 into yn. Okay, now further, let us see about the other terms, that is x y1 and a square y. Okay, we'll do that now. Now let us find dn of x y1. Okay, so this would be x yn plus 1 plus nc1 into 1 into yn, right? Or we can write this as x yn plus 1 plus n y, right? And the last one, which is a square y. So here a square is constant, so this will be a square, and for dn of y will be y. Okay, now let us substitute all which we have found. Okay, yeah, so this will be the first one, that is 1 minus x square yn plus 2 minus 2n x yn plus 1 minus n into n minus 1 yn minus x yn plus 1 plus n into yn, okay, plus
Yes.
a square yn is equal to 0. So hence we obtain the final result, that is this as 1 minus x square yn plus 2 and minus 2n plus 1 x into yn plus 1 minus n square minus a square into yn, which is equal to 0, right? So we got this result now. Okay. Okay, now let us say this, right? If we have there is x is equal to tan of log y, okay, and we need to prove that 1 plus x square into yn plus 1 plus 2mx minus 1 into yn plus n into n minus 1 yn minus 1, which is equal to 0. Yeah. So let us see this. How do we solve this? Okay. Again, by considering x as tan log y. Okay. Or we can write as log y is equal to tan inverse x. Okay. Or y is equal to e to the power of tan inverse x. Okay. So if you remove log, right, so since it is a log y to the base e, right, so tan inverse x, so this will be y is equal to e to the power of tan inverse y. That's how we got it. Okay. Okay, so we got y. Okay, now let us find what is y1. y1 will be e to the power of tan inverse x, right, into differentiation of tan inverse x will be 1 plus x square, or we can write this as y by 1 plus x square, because y is e to the power of tan inverse x. Okay, so y1 is y by 1 plus x square, or we can write this as 1 plus x square into y1, which is minus y is equal to 0. Okay, now we'll apply or differentiate n times term by term by using Leibniz theorem. Okay, so we should start that. Yeah, let us by using the Leibniz theorem, we have that is 1 plus x square, right, into yn plus 1, okay, plus n into 2x to yn plus n n into n minus 1 by 1 into 2, right, into 2yn minus 1. Okay, so this is done, and the last term which we have yn, okay, for y, or simply we can write this as 1 plus x square into yn plus 1, okay, plus 2nx minus 1, okay, into yn plus n into n minus 1 into yn minus 1. 0. So hence we got this result. Okay. Yeah.
Yes.
Okay. Okay. Yeah.
Sounds